Good evening, Shamori. How are you?
I'm doing pretty good, sir. How about you?
Well, I wish I were you because I'm lying here and dropping asleep.
Well, I'm sitting here and dropping asleep. So
Ah,
none
I
of
guess
us
both
are
of us are good.
better.
I guess both of us are good then. Were you able to watch any of the recordings?
That is recording. No, I haven't watched any recording, so I wasn't able to.
Okay. All right. Let us just wait then and see if by 15 past the others will join us, no?
All right, sir.
Bless Papa. Cool. Hey, Shamar, don't forget, so we have class tonight.
Pardon me, sir.
Don't forget, so we have class tonight.
Sir, look, sir.
Mm-mm. Drop something in the WhatsApp group, please. Let them know so it's about. All right. Good afternoon again, yeah, because everybody look like them on a vacation. So let us go. Let us start. So we're on to unit 2. We have completed our unit 1, and I'm feeling confident enough that you guys understand. Um, so let us attempt unit 2 and let's look at some conditions for continuity. There are 3 conditions, and I would love for you to just read through those conditions. Just read through them about a couple times over, and then I'm going to come and explain it. This is a possible multiple choice question for you to understand what continuity is. There are 3 conditions for continuity to take place. And then we're going to be looking at some examples of continuity, if a function is continuous or the function is discontinuous. So look at those 3 conditions for me. I'll give you about 5 minutes to just read through and read it over and read it over and read it over. I'll come and explain, and then we'll start moving into some calculations. Thank you. All right. Now, the statement and condition for continuity says f of a must exist. The value of f of a must exist. And then, if f of a exists, then I'm able to find the limit as x tends to a to the right of the function f of x. And it should be equal to the limit as x tends to a to the left of f of x. And then I'm going to say that the limit as x tends to a of f of x exists. Do you remember, you know, the other day I was looking for this, and it's as if I couldn't remember where to find it. It's like I just couldn't remember. And then it just, I have an aha moment. So what is this? The limit as x tends to a superscript plus. What does that mean? Anybody remember? Remembers? The limit as x tends to a superscript plus of f of x, and then the limit as x tends to a to the minus of f of x. What those plus and the minus mean again?
The left and right hand side.
Very good, Simon Sonson. I like when you're listening to the corrections of your teacher, you know. And I told her the last class, and I'm going to say to you again, you do this, you must pass the course. All right, keep it up. Very good. So Simon, not Simon, but Shamari. So this is saying that the limit as x tends to a to the right of f of x is going to be equal to the limit as x tends to the left of a, f of x. So what it is that we're doing is, right here is the intuitive approach. The intuitive approach. So the left-hand side and the right-hand side of the limit must exist. If they are equal, then I can say the limit as x tends to a of f of x exists. So this is like the intuitive approach. I'm finding the limit as x tends to 1. I'm going to look to the left of 1, look to the right of 1. If both of them are equal, we say that the limits are of a good behavior, and the limit of the function x tends to 1 of the function exists. And then I can say no, that f of a is going to be equals to the limit as x tends to a of f of x. So both supposed to be equal. And those are the conditions for continuity. Here now. Sometimes I've seen on exam papers before where the question says, for 3 marks, state the conditions for continuity. And your answer to that question will be f of a exists, then the limit of the function to the right must be equal to the limit of the function to the left, and then we can see the limit of the function as it tends to a of f of x exists, and then both of them supposed to be equal. F of a is going to be equals to the limit as x tends to a of f of x. Easy 1, 2, 3. And as we continue the questions, especially when you move on to piecewise function, you will see more of this. So this is going to be very critical for us. Now, we're just going to look at some very quick questions on continuity. It says to find the value of x for which f of x is equal to 1 over x squared plus 9x plus 20. We're checking to see where that function is discontinuous. When we have a rational function, we know that the rational function is going to be discontinuous when the denominator is equal to 0. When the denominator is equal to 0, the function is going to be discontinuous. All right? Every single time, barring none.
Repeat that, please, sir.
The function is on the screen. The function is undefined when the denominator is equal to 0 every single time. So if you're going to the exam and the question says, f of x is equal to 1 over x squared plus 9x plus 20. State the values of x for which the function is undefined or discontinuous, whatever the situation is. Your first statement should be the function is undefined. Or you can say discontinuous when the denominator is equal to 0. That condition happens every single time. So, you know, when you put something over 0 on a calculator, it says math error. For calculus 1, calculus 2, we speak about it being undefined. So we now need to factorize x squared plus 9x plus 20. We need to factorize x squared plus 9x plus 20. Let me ask you a question. I need to find 2 factors. When multiplied together, I need to factorize this thing here. So what 2 factors can I use to factorize this stuff here?
Four and 5.
Because 4 times 5 is 20 and 4 plus 5 is 9, don't?
Yes, sir.
Agree, Simon?
Yes, sir.
Good. So what I'm going to be doing is to multiply the coefficient of x squared by the constant. The coefficient of x squared is a number in front of x squared. The coefficient of x squared is a number in front of x squared, which is 1. There's a 1 in front of x squared. So I'm not seeing it. Yeah, it's understood that there is 1x squared. But sir, why it's not there? Because I don't have to write it. But sir, if I do write it, would I be wrong? No. But you just don't have to write it. Right? It is understood that it's a 1. So it is that 1, the coefficient of x squared, that I'm going to be multiplying by 20. When I multiply 1 by 20, I'm going to get 20. Now I need two numbers. When I multiply together, will give me 20. But when those two numbers are added, I'll get 9. And yes, Shamari, you're correct. Because 5 times 4 is 20. And when I add 5 to 4, I'm going to get 9. So my factors, yes, are indeed 5 and 4. My factors are indeed 5 and 4. So I am going to be breaking up this 9x here into two factors of 5x and 4x. Then I'm going to be grouping. That's one of the reasons I broke it up. Because if I'm factorizing that grouping, I can't have equal numbers of factors in with 3 terms. I need an even number of terms. So when I break it up, I'm going to get 5x plus 4x. Then you say to me, sir, I see you at the bigger number first. Does it matter? It really doesn't. If I'd written 4x first before the 5x, I would still get the same answer. All right? So when I'm going to be grouping now, I'm going to put the first 2 in parentheses. See there, I have x squared plus 5. I will always leave the middle sign out. When I'm factorizing, I will always leave the middle sign out. Why, sir? Because it's not a multiplication that we're trying to find at this stage. We're trying to factorize. So we're going to leave the middle sign out at this stage. Every time we do a factorization question of this nature, the middle sign will be left out. And then I'm going to be doing the grouping the last 2 sets of terms, which is my 4x plus 20. I'm going to ask myself the question, what is common here that is common here? And you'll recognize that x is common here and it is it's also common here. So I'm factoring out an x. Then I'm going to ask myself the question, what is left? When I factor out x from x squared, I'm going to have x remaining. When I factor out x from 5x, I'm going to have 5 remaining. And we can double check to see if we're correct now. X multiplied by x gives me x squared. And this x multiplied by 5 will give me 5x. So I know that I've done my factorization here correctly. Similarly, I'm going to look to see what is common between 4x and 20. And when I look, I recognize that 4 is common here. So it is here. So I'm factoring out the 4. And when I factor out my 4, I'm going to be left with x plus 5. And we can double check. 4 times x is 4x. And 4 times 5 is going to be 20. Okay, watch me now. I'm going to look to see what is common here in this stuff. And when I look, I recognize and I try to color code it so that you can see clearly. The ones in pink are common, x plus 5 times x plus 5. So I'm going to factor out my x plus 5. When I remove the x plus 5 from here, I'm going to have this x in blue and I write it back. And when I remove the x plus 5 from this side, I'm going to have my positive 4 and I write it back. So whatsoever is in blue will come together in one parentheses, and the 2 things in here will also come together in one parentheses to give me my answer. All right, so that's how I end up getting my question. Are we okay so far with that?
Yes, sir. And you said that whenever we have a rational function and the denominator equals 0, it's always discontinuous.
Yes. And another name for that is undefined. Yes.
And so the denominator is equal to 0 just because it's a quadratic expression in the denominator.
Yeah, no, you are going to set the function equals to 0, you know. So it could be anything. It don't have to be a quadratic. I could give you x plus 5 and ask you to state the value of x for which the function is undefined. So you are going to say, let x plus 5 be equal to 0. So they won't give you 0 in it, you know. You have to then make your first statement. Let the denominator equal to 0. You follow me?
Yes, sir.
Yeah, man. So when they give you the question, they're not going to say, put the denominator equals to 0 and solve. Nope. Let me read what the question can be. The question will say to you, find the values of x for which f of x is, which is equal to 1 over x squared plus 9x plus 20 is discontinuous or undefined. You, the learner, must know that for discontinuity, the denominator is equal to 0. Once you have that statement, you get 1 mark. Once you have that statement, you get 1 mark. And then once you factorize the quadratic properly, you can get either 3 marks or 4 marks. So normally the question is a 3 mark or a 4 mark. And I'm going to tell you, very recently in the exams that just went, this is what saved one student between a passing grade and a failing grade. All right? So I'm saying to you, very important concept. Just the mere fact that you write your mathematical statements. Don't keep it into your head and say, I know this. No. Put it on paper and demonstrate to me that, listen, sir, I know what it is and I understood what it is that you taught. And fling it on the paper and give to me. I will have to fling back the marks and give to you. Real talk. All right? So don't keep the information in your head and then expect it to pass. And say, but sir, I know it and I understand it. Demonstrate to me. Because when I mark your papers are second marked, moderated by an external person. When I don't see the grade, I can't say, oh, I know that they knew it. The moderator will say, no, but I want to know too. And if I give you a passing grade, the moderator will say, no, the student deserves to fail. So you have to put it down on paper. Yeah, man, you pay a school fee. We have enough papers to give you. Write it down on paper, let me know. All right? And then now, because you're setting it equals to 0, question is not finished here. We know how to find out what happens when x plus 4 equals 0 and what also happens when x plus 5 is equal to 0. And we will know that when x plus 4 is equal to 0, the value of x that makes this true will be negative 4. So this value goes to negative 4, and this value goes to negative 5. And the question did say, the values. How do I know that I was going to have two values? The question says values. Values is plural. It could be 2 or more. I got 2 for my answer. 2 values for my answer. X equals negative 4 and x equals negative 5. How do I know that those are correct? That is only 2 values I should have.
So the reason you got the 2 values and you knew that you would get more than 1 value is because it's a quadratic expression and you're gonna have 2 values when you factorize a quadratic expression.
How do you know that? I want you to tell me how you know that, Shamari. You're correct, incidentally. But tell me how you know that when you solve a quadratic equation. Okay, let me help you out. When you solve a cubic equation, how many values you get?
3, just guessing.
Okay, and that's an intelligent guess. When you solve a quartic equation, how many values you get?
Is that 4?
And you're correct. So do you see a relationship here now? A quadratic you get 2, a cubic you get 3, a quartic you get 4. Any relationship so far?
Because you have the power of x is square.
Very good. You see how math's easy? I didn't tell you that, but because I put 2 more examples together, you're able to figure it out. So the highest power in your expression tells you how many values of x you have. So not just because it's a quadratic, right? Not because it's because of the power that it's raised to. So I have 2 values. I have the power 2, the exponent 2. So because I have the exponent 2, it tells me that I have 2 sets of values. The exponent 3 tells me that I have 3 values. The exponent 4 tells me that I have 4 values. The exponent 10 tells me that I have 10 values. So once I look at the function, if they had given me a cubic equation on there, I better find 3. Because if I find 2, it means that one of the values incorrect. Is missing. All right? So it gives you the sets of values, all right? And then now, the question finish. I can prove it. I can prove it. Let me prove it here with the first one. We are saying that x is equal to -4. All I'm going to be doing is anywhere in the function x, in the function f of x, sorry, I see x, I'm going to substitute -4. So -4 squares is going to be equal to 16. And 9 times -4 is going to be -36. And I put back my plus 20. 16 minus 36 is -20, and -20 plus 20 is 0. So I get 1 over 0. That is undefined. 1 over 0 cannot exist. There is no value that can sit atop 0. You can't have a 0 existing in the denominator at no point in time at all. Not yesterday, not today, nor tomorrow. But sir, you can have 0 in the numerator. Absolutely. Absolutely. And if you can recall, when we did our limits, when the highest power of the limit is in the numerator, do you recognize that we are going to get our function to be undefined? Because all the other values in the denominator will be 0, 0, 0, 0. You remember that one?
Yes, sir.
Yeah, man. And that's a reason. That's the reason. 0 cannot exist in the denominator. And if you check the other one, anywhere in the function, again, I see x, I put 5. 5 squares is 25. And 9 times 5 is 45. And I write back my 20. 25 minus 45 is -20. And -20 plus 20 is 0. So I know that I'm correct. So just remember, whenever they give you a question to say, determine the value or the values of x for which the function, boom, is undefined. Go right ahead, set the denominator equals to 0. And I'm going to tell you something. You see, if the numerator have a number other than 1 inside of it, don't worry about it. Sometimes they give you the question and put the numerator like here, so. And see right here, so Shamari, this is a 2018 past paper. How many values of answers I'm supposed to have in here?
3.
3, because this is a cubic equation. Don't matter that you have 9x minus 10 in the numerator. This 9x minus 10 have nothing to do with the question. We are totally ignoring the numerator because the numerator can be any value. We are not concerned with the numerator. We are only going to be concerned with the denominator when it is that we are checking whether or not a function, looking at the points of discontinuity. We're not concerned with the numerator. No matter what in the numerator, leave it alone. It doesn't concern us. What concerns us is what is in the denominator. All right, so let me give you a question to do for me. It says, find the values of x for which f of x is equals to 1 over x squared plus 15x plus 56 is discontinuous. I'm going to ask that you try that for me, please. I'm going to give you 2 minutes. I want you to try that for me. You must remember how to factorize. If you don't, problems. So go ahead and factorize this for me quickly, and then we can move into some other practice questions. This is a pretty easy topic, so I'm not going to be spending much more time on it. For sure, by 7:15, we're off this topic, right? So I have quite a bit of questions. I won't give you all the questions. I'll just jump around and give you maybe 2 or 3 more questions or 4 more questions at a maximum, and then we'll move on. So try and catch on to this, please. Start for me. Thank you. Please, when you're finished, let me know I'm right here. I've just muted. Let me know when you're finished, please, so we can go through the question. I need to work so we can get our practice. Thank you.
Yes, sir, I'm finished. Or single out something.
You are finished. Shamari, how is it?
Finished as well, sir.
Nice. Good afternoon, Adrian.
Sir? Afternoon. Sorry.
You just slide into the eye class and don't be ill of the eye. What kind of foolishness that? Are you finished, Adrian? Adrian. Jesus, Adrian gone again. All right, let's go. Give me one answer, Shamari, and Simon, give me another answer. So whichever one speaks first and give me an answer, the other one gives me the other answer.
-7.
Simon, you agree?
Yes, sir.
What's the other answer, Simon?
-8.
Do you agree, Shamari?
Yes, sir, I agree.
Adrian. All right. Adrian is not with us. Very good, guys. Very good. So I don't need to go through this because the peer review answered me correctly. Adrian is not here. I have another one to give you. Now I'm going to give you less than the 3 minutes because you guys understanding what to do. There goes another question. Question number 3. Start from it, please. Always stay.
Finish
Sir,
it.
a million sorry. We never get to hear the last part.
You know, serious, you know, Adrian. You know,
No, man,
serious.
sir. Sir, right
Yes.
now me there work, sir. And the seriousness of the job me have to up and down.
Yeah, but
Very serious.
say something on, I mean, I'm calling you, you're not answering, and we'll move on to another question. I ask you if you're understanding, not getting
No, sir,
anything.
me have the screenshots them, you know. I'm gonna
Not,
start watch recordings them.
yeah, but that alone now work. Me want when you come a class, you something has to work for me, and you have to go talk one away because I'm already beginning to worry. I'm beginning to worry. So me and you have to go have a one. Yeah.
Really, I'm not a failure.
Yeah, man. We have to go talk offline, all right?
Ah, no problem, sir. No
Mhm.
problem.
All right, guys. So what answers do you think we have right here for number 3?
We're gonna have. I should give it both answers.
Go ahead.
-6 or 1.
Do you agree? Simon, do you agree?
Oh, +6. I have.
I would agree with you, Simon, that is +6. Well, let me tell you why. Your factor will be +6 here in order to get your +5. But when you get your +6 right here, remember when it is that you set it equals to 0, it's going to become a -6. You follow me, Simon?
Yes, sir.
Good. So I agree with you with the +6 because in order for you to get your +5, it has to be a +6 and a -1. So +6 and -1 will give you a +5. But remember, when you set your +6 now equals to 0, you're going to end up with a -6. And your -1 is going to end up with a +1. So when I so technically what is going to be true is that you're going to have x plus 6, but you're now asking yourself the question, what value of x when added to x plus 6 will give you 0? The answer is going to be -6. Get that?
Yes, sir. I saw where I made a mistake.
Okay, good job. Happy that you see the mistake. All right. I'm going to give you one more. I'm giving you one more, and then I'm going to jump into two difficult ones, and then we'll call it a day. So, on the mark, get set, go again for that one.
Finished, sir.
What's the answer, Shamari?
When x equal 2 or 3.
Say the answer again, please, Shamari.
2 or 3.
Do you agree, Simon?
Yes, sir.
Okay. Excellent work. I won't give you that one to do, but I will move on to this one, 2008 part 18 past paper. I want you to be diligent with working this question. It is worked in a similar manner as for the others. Don't be daunted by it. Remember what teacher says. Teacher is saying we are ignoring the numerator. We are only focusing on the denominator. The question says find all the points of discontinuity of the function. How do we find the points of discontinuity? We let the denominator be equal to 0. Yes, you must start off by writing that statement. Let the denominator equal to 0. You're going to let the denominator here equal to 0. You're going to let the denominator equal to 0. You're going to let the denominator equal to 0. You must start off with it. Let the denominator there be equal to 0. All right? Right here. So you have to start off with it by letting the denominator equals to 0. Okay, on the mark, get set and go. Start from it, please.
Sir, I'm a bit stuck.
Why? What
So
happened?
because the x to the cube minus 4x, I don't know how to.
Equals 0. And then what happened? What do you recognize with that question? X cubed minus 4x. What's the first thing that should come to mind in solving that question? I should say x cubed minus 4x equals 0 in solving. What I had said before was an expression, and you can't solve an expression. So what's the first thing that should come to mind when you see x cubed minus 4x equals 0? Are you seeing anything in common right there?
Oh, sir.
Mm-hmm. You have x is common to x squared and x is common to 4x.
I see.
Mm-hmm. So since you're common there, what is your no what is now your reaction? What are you going to be doing? How are you going to perform it? By doing what?
Breaking it down or
No man, I need a correct word. You're going to
factor,
mm-hmm. Say it again.
factorize.
Yes, man. So factor out of x. Factor out of x, and then after that, you're gonna have something else to do. So start working again. Shamari, are you with me?
Yes, sir, I'm with you.
Mm. I don't want to project the answers, the solution to the question yet, because I really want you I want to create. I'm trying to develop independent thinkers. If you are very good at mathematics, there's no way anything in programming or anything that you have to do in your other areas, your management, accounting, should give you problems. So I'm trying from this end to help to develop your spatial awareness and your mathematical abilities. All right. When you get stuck again or when you finish your question, let me know.
think I'm done enough, sir.
So are you finished now, Shamari?
I think so. I did
All right.
something.
All right, no problem. Simon, do you have a final answer for me just yet?
Yes, sir.
All right. I'm going to project something, look at it, and tell me if you agree. And look to see what it is I've done. Give me 2 minutes, I'll come back to you. The answer is being projected.
Sir, the x equals 0, x equal -2, or x equal 2, that's the final answer?
Yes, sir. Those are the final answers. But what I want you to do is to look at my solution. You see that I use it in 4 lines, 5 lines? I want you to look at it. Look at it and just double check to see what it is that I have is something that you can reproduce on your own. All right?
Sir, question line 2. Is it that we can always say we take away 1x if it's the same question like this? No, that's line 2.
I know, sir. I know where line 2 is, but I was saying to you, at the time when I was calling, they weren't answering. That's exactly what I was explaining to the students. What was common here, that is common here. Do you recognize that x cube and
Yes.
4x, that there's something common between the x cube and the 4x?
Yes, sir.
So that's why I took out the x. So when I asked the question, I think Simon was the one who answered me. I asked Simon, what would be the procedure in first attacking this question? And because there is something that is common, once there's something common in mathematics, what it is that we're going to be doing is factorizing. So the x's are common, so I'm going to head and factorize. This is the shorter of 2 methods to work the question. So when I factorize, I'm going to be having x squared minus 4. And
okay,
you should recognize that x squared minus 4 is a difference of 2 squares. That's why I was able to just go ahead and write x plus 2 times x minus 2. You see that?
Yes, sir.
All right, cool. Go on look and make sure you write it up. I don't like the idea, son, that you are just screenshotting. Screenshotting alone won't help you for calculus 1. You must write. When you write, it puts the information to long-term memory. So I don't want the screenshot because something can happen to one of the shots and you get shot.
Yes, sir.
Real talk. I want you to write, so start writing. All right. Continue looking, please. It's very important. When you finish that one, Simon and Shamari, I know you're finished. You can do this question for me, please. This one is h of x, 7x squared minus 8 over x squared plus 5x minus 6. State the values of x for which a function is discontinuous. Adrian, look over this one more time, and then you join the others for that other question, please. I soon move on from this topic, I did say 7:15, it's now 7:30. So do that one for me. This is the last question, and then we'll move on. So hold on, you know. So if me no say thing, uno say. Finish. Nobody not gonna tell me say sorry, we finish. You guys are done now with it?
Yes, sir, we're finished. I'm finished.
Okay.
Sir, you can go ahead.
Thank you, Papa. All right. Sorry, I was just responding to a message. No, I shouldn't have. What's the answer?
One or -6.
You agree, Simon?
Yes, sir.
See, topic done. It don't make sense when you know more because when I get it. Heslop, can you talk? Nice. So I guess not. Very nice. So what I'm going to be doing now is moving into some piecewise functions. I'm moving into some piecewise functions. Now, it's not difficult. You guys, I can tell you understand limits. You guys were able to figure out different rules in limits. Piecewise function is not difficult. Let me encourage you by saying on the exam paper, you can find a piecewise question for 10 marks, 15 marks. It is one of those areas that is a must-have. If you can understand piecewise function, you can do the question and you can pass the course. Real, down-to-earth talk. I want you to come to this piecewise function tonight so you can have full understanding. Okay, sir. All right, I want to have fulsome understanding as to what is happening. So hear me out. I'm going to try and develop the conversation on piecewise function. So the conversation is this. You are going to need some prerequisite knowledge. What are the prerequisite knowledge? You need to know your factorization. And your factorization would be things like your perfect squares, things like your difference of squares, factorization by grouping. All right. And once you can remember those, you should be good to go. I'm not going to go through these two in the interest of time, because what it is that we did just now was to look at points of discontinuity where all those questions were quadratic. And sorry, Shamari, did you say to me that in one class that the factorization was beating you for something? I'm just trying to remember. It's like deja vu. Was it you?
Yes, it was me because the x squared had a coefficient other than 1.
Other than 1. Were you able to look at those, or you still have a problem with it?
I was able to yeah, it helped me figure it out.
Okay, then good job. I was just going through this and then I remember that somebody had said it and I was wondering if it was you. All right, I'm happy about it, son. It's very important, that as you go along, if it is that you're not understanding something, talk to teacher. I am here to help you. This is a Friday night. I should be out, or I should be sleeping or something. But I am, I was saying to Shamari earlier that I am here waiting for the start of class and drop asleep in. And Shamari says, sir, I am here sitting up waiting for class and I'm falling asleep myself. But it's just a commitment that we have to the process. And are you hearing me?
Yes, sir, I'm hearing you.
Sorry,
No.
were you hearing me, guys? Oh no.
Yes, sir, we're
Yes.
hearing you.
Okay, right. So it's a commitment that we have to the process, and I'm going to ask you to just remain committed. If you stick with me, you will pass the course. I don't want anybody to fail the course at all. Just stick with me, no man, and do what you're supposed to do. If you do what you're supposed to do, you know, and follow my guide and follow my leading, you'll be good to go. So for example, this is what a piecewise function looks like. That's what a piecewise function looks like. And piecewise because this function f of x has one equation, two equations, well, one expression up here, so another expression here, so and another expression here. So piecewise because it's not just one, but it is all of three of them. And this one is going to depend on this one, is going to depend on this one. So we're looking now at something that is going, that we can represent graphically to see if the function f of x, that all three over here are related to this same f of x. If when I plot the graph, I'm going to have something that is continuous or something that is going to be discontinuous. I'm looking, remember what we're looking at? Is continuity. And we want to find out if, it's just an investigation. Is the function continuous or the function discontinuous? Right? It's just a conversation, and we have to use mathematics now to evaluate what is happening. So I want you to work with me. I'm going to ask you as best as possible. Watch the screen. Watch the screen because I'm going to use it to help with the explanation. And there are several things that I'm going to be pointing out. I know you're going to have a recording, but I want you to look at what I'm going to be doing. I'm going to go as slow as possible so that you can understand the first example, and I will leave you to do the second example and guide you accordingly. Watch me. It says determine if f of x is continuous at x equals -2 and x equals +2. Given that f of x is 2x minus 1, such that semicolon means such that x is less than -2. So this expression here, 2x minus 1, only relates to those values where x is going to be less than -2. So a value that is less than -2 will be -3, -4, -5, -6, and so forth and so on. So those numbers will only be relating to this first equation here. Then the second one says x minus 3, but the condition now is closed. Why closer? Because x is supposed to be greater than -2, but it's supposed to be less than or equals to 2. So what that mean? Thank you for asking. So this one here up top was less than -2. This one here is going to be greater than -2. So greater than -2 means that it's going to be -1, 0, 1. But this one says it is less than 2 or it can be equals to 2. So I'm going to say 2. I can't go to 3. Why? Because it says that this one here is less than or equals to 2. But this last one says, hey, x minus 1 is such that x is greater than, or it could also be equals to 2. Oh, so this one is when the value is less than 2. This one is when the value is between -2 and 2. And this one is when it is going to be greater than 2, right? So you see some connections here because this one say it is less than or equals to 2. And this one say, oh, it is greater than or equals to 2. So there's some equality right here going on. But we can talk more about that. So we have two conditions. Condition number 1 is when x is equals to -2. And condition number 2 is when x is going to be equals to +2. So one is when it is equals to -2, and one is when it's equals to +2. So sir is going to start at x equals -2. We're looking at the conditions. Remember, we spoke earlier about the conditions for continuity. We spoke earlier about the conditions for continuity. All right? We now need to look at the conditions here, and those conditions will fit into the explanation that we're doing here. I'm looking at the value of x when it is equal to -2. As a result of that, I need to properly investigate to the left of -2 and to the right of -2, as the condition of continuity says. Remember, f of a must exist. I must have a function that I can substitute a value a into the function. If I can't substitute a value a into the function, it don't make no sense. All right? So like we have 2x minus 1. It means that f of a must exist, and that was the first condition to it. Then it says the limit as x tends to a of f of x must be equals to the limit, start again, the limit as a tends to the left of f of x must be equals to the limit as x tends to a to the right of a of f of x. If those two are equal, then the limit as x tends to a of f of x exists. Sir, your talk, I mean, I know where your talk say. Not lie to you, sir. Okay, not a problem. Let us go back to the start of continuity. So f of a must exist. And then what I'm saying, just like we have the 3x, the 2x minus 1, I can substitute a value in my f of x. See it here, the value that I'm substituting is x equals a. So once it is that I can go ahead and substitute something in there, then I can say that it exists. Then no, x is going to be equal to a now. So I'm going to say to you the limit as x tends to a to the left, well, this one says to the right, but same difference. As x tends to the right of f of x must be equals to the limit as x tends to the left of f of x, which is also going to be equals to the limit as x tends to a of f of x must exist. So remember we said when we were looking at the intuitive approach that once the left-hand side is equals to the right-hand side of a number, it means that the function is of a good behavior and the limit exists. See it here, so f of x, the limit as x tends to a of f of x exists. And then the third condition now is that f of a must be equals to the limit as x tends to a of f of x. So once these three conditions are met, then I can have continuity taking place. Let me fast forward now to what it is that we're doing here. I must investigate the limit of the function to the left of -2, see here, superscript minus, and I also must investigate the limit of the function as it goes to the right of -2, see here, f of x tends to -2 to the right. So one tends to the left and one tends to the right. And I must investigate those. Now, if both answers come out to the same, like it does here, then I'm going to say, since the limit to the left is equals to the limit to the right, then f of x is continuous. Then f of x is continuous. If they are not equal, as in this case, one is -1 and one is +1, then we say that the function is discontinuous. All right. So the conditions for continuity is going to play out right here, so we know what exactly that we're playing around with. So let us go through the question now. We have an hour left. Let me see if I can finish off this topic, the unit on continuity. Well, I won't be able to finish off the unit on continuity, but maybe to just move into continuity, and we don't have to go through all these questions. No, I won't be able to finish it because there are some other variations to the continuity that I will need to do. For example, when you have some unknowns in it, but it's the same level of conversation. So if you understand what I'm doing up there, this really shouldn't be an issue, but I need to do that. And then I gave you some summary of what is happening there. Well, I have some summary, then I looked at some past papers, and then I need to move into some differentiation. So I won't be able to finish, but to give you a sense of what is happening here. All right, so this is where we are. So I'm investigating to the left of -2. I'm investigating to the left of -2. The investigation begins now. So to the left of -2, let us go back to my question. And my question gave me something here that says 2x minus 1 is less than negative 2. So that means this function is going to deal with to the left. Once it is less than, it's to the left that we're going. Think back at a number line. Think back at a number line. And I want you to think of 0. On that number line. Think of 0 on that number line. When you think of 0 on that number line, the values to the left of that 0, are they greater than or less than 0?
Less than 0, sir.
Very good, Adrian. Thank you for being there and answering. They are less than 0. So when I go to the left, then it's going to be less than. And the other one has to be the opposite. Once I go to the right, it's going to be greater than. All right? So this function up here, 2x minus 1, is a function that is going to deal with going to the left. All right? So I'm going to identify that as the function. See down here, it says x tends to negative 2 to the left. So because I'm going negative 2 to the left, it means that I have to use a 2x minus 1. And this 2x minus 1, anywhere in the function I see x, I'm substituting the function 2, negative 2. So it's now going to become 2 times negative 2, which is negative 4, and negative 4 minus 1 is negative 5. Then now, since I investigate to the left, I must also now investigate to the right. So I'm looking to the right of negative 2. To the right of negative 2, I can't use this function because this function already said to the left. I'm looking to the right of negative 2. Can I use this function here down here, the x minus 1?
No, sir.
Tell me why I can't use this function down here, so.
Because the negative 1 is higher than negative 2.
All right. So that's exactly what it is. I can't do that. This one here says negative 2, but this one here says positive 2 right here. So this have nothing to do with it. So I have to go to this function here now that says, when I look at my double inequality, I'm going to forget about this piece here that I'm covering up. I'm not interested in this piece yet. So here I'm going to say x is greater than negative 2. Oh, but if it is greater than, sir, it is to the right. So I'm going to be looking at the right, and the right is going to be x minus 3. So I'm going to use a function x minus 3. And anywhere in the function I see x, I'm substituting 3. So because I'm talking about negative 2, it's going to be negative 2 minus 3, which is going to give me negative 5. And since the limit to the left is equal to the limit to the right, then the function is continuous. I'm giving you a 1-minute pause to read through all I have right here. So on your own, and then I will entertain your questions before I move on. Start reading now. Obviously. Any questions?
Yes, sir. Could you just reiterate why you couldn't use the last equation of x minus 1 such that x is greater than or equal to 2?
What kind of two is it?
It's a positive 2.
Which one am I which one am I investigating up here? Where's my cursor?
Negative 2.
Ah, you see it?
Yes, sir.
So you know definitely I have to use this equation because this one is negative 2. Talk through this function, not equation, but this function. I have to use a function 2x minus 1 down because the condition relates to negative 2. Don't.
Yes, sir.
I can't use this one because this one relates to positive 2. So the only other function I can use is this one because this one also has a negative 2 and a positive 2 in there. So I'm going to use this function 2 times because this one relates to this one with the negative 2 and this one relates to this one with the positive 2. So that's, I can't use this one none at all. Tell me, say that.
I see.
Any other questions?
No questions for me yet, sir.
Okay. Let's continue. No, Shamari. We are going to investigate at x equals 2. See, Tresson? At x equals 2. Shamari, now that I'm investigating at x equals 2, can I use this function up here, sir?
No, sir.
Why?
Because it's relative to minus 2.
Very good. So you're learning. I know Simon understands this already. Okay. So that's correct. So now, if that is the case, and I know I can't use this one up here, the only ones in my conversation then will have to be these two, don't it?
So it will always be 2 out of the 3 expressions.
No. I can give you a question where there are 4 equations. And I also can give you a question where there are only 2 equations. Two. I can give you a piecewise function with 2 other functions. And I can give you a piecewise function like this one with 3 functions. I can also give you a piecewise function with 4 functions in there.
Okay,
but I'm just showing you as many ways that you can look at the function. The best way to look at the function is the inequalities. But having found the inequalities, you can also look at the function another way. So I'm showing you both ways so that at least when you see the question, you can know exactly what to do. All right. So let us look at x equals 2. So at x equals 2, I have to look at again both the left and right of the function. I have to look at both left and right of the function. All right. So I'm looking at the left of the function first. Now look and see which of the equations now. These are the left. This one says x is less than or equals to 2. The mere fact that it is less than, it means that it's going to the left. So the function that deals with to the left of 2 has to be x minus 3. It has to be x minus 3. So when I go here now, to the left of 2 is going to be x minus 3. And anywhere in the function I see x, I am going to substitute the value 2. So x minus 3 is going to become 2 minus 3. And 2 minus 3 is going to be equal to negative 1. 2 minus 3 is going to be equal to negative 1. Similarly, I'm going to be looking at when x tends to 2, but this time I'm going to be looking to the right. Looking to the right. So when I look at the function, I recognize that this is x minus 1 such that x is greater than 2. Once it is greater than, it is going to the right. So therefore, the function x minus 1 corresponds to what I'm talking about right here. So I'm going to have 2 minus 1, which is equals to 1. Negative 1 and positive 1 are not the same things. So I can conclude by saying Since the limit as x tends to -2 of x minus 3 is not equal to the limit as x tends to 2 to the right of x minus 1, then f of x is discontinuous. It's not a continuous function. It's going to be discontinuous. Right? And then that's the end of the question. I have some things for you to note. I have something for you to note. And I want you to take note of it. And I'm going to read through them and then give you an opportunity to write off the stuff. You will have this, so you don't need to necessarily write this off, but I want you to write the question as I go through. So to the left means less than. We've already established that. To the left means less than. And to the right means greater than. And I want you to stop and think back to the number line. And we've done that in class a while ago already. Think of the number line. When you go to the left of the number line, you're less than. When you go to the right of the number line, you're greater than. Number 2, x tends to -2 to the superscript here, -2 to the left. It means to the left of -2. So this negative sign here, superscript, means to the left. And a positive sign means to the right. Just remember that. So when you're doing the stuff, you have to write for me like that. So that I can know where you're going, left or right. All right? Now, when you have the double inequality, what do I do? Okay. We're going to start at the x, and I'm going to be reading inside out. What do you mean by inside out, sir? Thanks for asking. You're starting at the x here. You need to read to the left. So that means it's going to be x is greater than -2. But this x is also less than or equal to +2. So you're starting at the x and you're reading inside out. So it is read x is greater than -2, that way you're first to the left. And then x is less than or equal to 2. See here, x is less than or equal to 2 to the right. And then since we read from left to right, once the inequality sign is open to you, then it is greater than. In other words, the mouth of the alligator is open. See it right yourself. And otherwise, it's going to be less than. The mouth of the alligator is closed. Right yourself. Right? So those are some things that I want you to note. You will get this. I'll send it to you. But what I want you to do is to take this question off. Let me just make sure that everything can hold on it. Good. Take that question off because I have some questions for you that I want us to practice on for the remainder of the class. Class, we have another 45 minutes. So take that off for me, please. Let me know when you finish taking it off. The first person to finish taking it off, just say something so that I can come back. All right, thanks. Can I move now to the question, or are you still writing?
Not that yet, sir. Still writing.
Let me know. Aren't you finished it yet?
Finished, sir.
Are you finished?
Finished, sir.
Yeah, man. So say something to me, no, man. I was waiting on you.
I
All right.
want
Are there any questions now on it? Is there anything that you see now that you're still not so clear about that you want to ask me? Or it is that you want to just go and try one and then maybe the questions will come?
let's try one, sir.
All right. Let me just use this and send to copy and copy that. There goes I do now. Don't worry about the fractional form in there is the same question. Don't worry about it. You'll be fine. Are you still seeing it?
Yes, sir. Seeing it.
Man, go ahead and start on it, please. Finish?
Yes, sir. Finished.
What you got for the answer?
I got that. It's continuous at both x equal -4 and x equal 1.
What you got, Simon?
So for at x equal -4, I got it was continuous. Yeah, both of them they are continuous.
Let me see if I agree with you. That's what you got?
Yes, sir.
Yes, sir.
What is an instant document? Hmm. Okay. Something went awry with my document just now, and I was wondering what was happening. Okay. Oh, so that's a problem. All right, very good. Heslop, you give an attempt on this, Papa?
Sir?
Were you able to give an attempt on this one?
No.
All right, that's all right. That's all right. All right, but if you can listen now, go and look still, I'd appreciate that. All
Yeah,
right, so
man, no
very good.
problem.
All right, cool. So very good, guys. That you see, and let me tell you what I appreciate about the class is that I did one example with you, and then I give you something fractional, and some students say, "Oh, Jesus, sir, but you never did no fractional work with this." So I taught you conceptually. So it means that any question at all that is presented to you, you should be able to answer it because you understand the concept. You understand the concept. So it's all about application and even to apply itself. One of the things that I normally often say to students you say if you know for cook chicken, or if you season up meat, or if you season up chicken in particular, you can season any meat. It's the process is similar. Now, as you go ahead and you develop your cooking skills, you'll recognize that okay, some meat can may take a little bit more than others because and it depends on the cut of the meat. If it's thicker, you may have to do a little bit more, etc., etc. Same difference. So just follow the procedure and you should be good to go. So yes, one-on-one equal. So therefore, it is going to be continuous at x equals -4. And similarly, it is going to be continuous at x equals 1 because they are both equal to 11. Now, importantly, you notice that the function here, you had 11, just 11 and nothing else. The limit of a constant is a constant itself. The limit of a constant is a constant itself. Excellent work, guys. I'm really proud of you. Keep it up. You are seeing Calculus 2. The Calculus 2 students, should be doing some work on Edico now, or listening to some long-time videos, because it is very important to keep afloat. Watch this. You ask a question, Shamari, and there goes one. So this question is going to be easier than the one that we just did because it has only two functions. So go ahead and give this an attempt for me, please. On the mark, get set, go. Finish? How is it?
Finish now, sir.
Is it continuous or discontinuous?
Discontinuous.
Sam, what do you say? You agree?
Yes, sir. It's discontinuous.
What values it got?
Read that, sir.
I'm just saying, what values it got when you did it?
-3, 0.
Good job. Excellent work. Excellent work. There goes another. The more you do, the better you get at it, the faster you get at it. So quick and fast.
Sir,
Let's stop.
all right. I realize class is almost over, so I have a question. So, remind me, how many units does calculus one have?
That's a good question. I don't remember.
All right. So basically, because we have calculus 1 and 2 in one semester, we have a cutoff to the units, or we still have to do everything like a regular calculus one in one regular semester.
The latter of the two is a response, because remember what you're doing is you're still, even though it's the two courses you're doing in one semester, each course is 60 hours long and you are getting the 60 hours. So you notice you have 7 hours of calculus for the
The week.
for the week, yeah. So normally you'd have had only 4 hours. So it's as if you're doubling up on the time in the semester. So you're getting more math this semester than you will normally get. Are you seeing my news? Are you seeing my Microsoft? Yeah, no?
Yeah, man. Yeah,
No,
man.
no, 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 no. I'm saying what are you seeing on the screen
That
now?
one. Where at the crane?
What are you seeing on the screen now?
No, man. They someone will just come.
No, man, I'm saying
Yeah.
I was trying to share my Microsoft. Are you seeing the Microsoft now?
Yes, sir. I'm seeing it.
All right.
That's
You
a
asked a
section.
question. Yeah, you asked a question and I didn't have the answer to it, but the answer to your question is very close. Let me go to tools. Let me go to syllabus. What?
I think it's 6.
No, but this is strange. I thought I had imported your syllabus from before. Hold on, this is not good.
All right, sir. I don't mean to cause a stress or panic or anything. I just wanted to know, but based
No,
on
no,
the
it's not.
answer
It's
you
not. It's
give
not.
me,
It's not stress or panic. Hold on, Adrian. It's not a stress or panic. I said that I thought your syllabus was um was there. So what I'm doing is I'm attaching the syllabus now so that you can have a look at it. But I'm not seeing.
them care you are the one them with the up there, so no?
Mute for me.
Okay. Oh, sorry.
All right, so that's the syllabus. The syllabus is now uploaded under your stuff. When you click on tools or you go to syllabus on the left-hand side. So let me just view something and calculus 1. So Simon says there are 6. So the first one is limit and theorems, and we've completed that one. With the exception of L'Hopital's rule. I can't do L'Hopital's rule yet because I don't do differentiation. So this one is out of place. All right, so don't worry about this one. That one have to be done. If you look here, you see it all the way down here. So again, because you should see it. Lordy. L'Hopital's rule. You should see L'Hopital somewhere down here. So right here. So you see L'Hopital's here again. So this is where it really supposed to be. It was an error when I put it up top there. So don't worry about that. I will definitely go through it. So yes, Adrian. So we have one unit. We're on to the second unit, continuity and differentiation. So I've done this point where I state the conditions for continuity of a function at a given point already. I'm determining if a rational or piecewise function is continuous at a point. That's what we're doing. Identify points of discontinuity in a graph representation of a function. I don't want to do any graphs just yet. I want to build some concept first before I do the graphs. After piecewise, my next topic is going to be differentiation, from first principles. And yeah, I'm going to finish differentiation from first principles. Then I move into the third topic. So I just have one more topic technically to finish continuity and differentiability. And that one topic to complete that unit 2 is my first principles differentiation. And then I'm going to move into differentiation. I'm hoping to move very quickly to differentiation. Then I move into integration. Those are some rules. Then I move into integration pretty quickly. Then I move into the applications, which is going to be the 5th one, applications of differentiation integration. I think that is it. The other unit is exponential and logarithmic function. Yeah, I need to teach you that also. But chances are, when I am doing differentiation and integration, because it says here differentiate explicit and implicit exponential and logarithmic function, I may do this in my differentiation up top and integrate exponential and logarithmic function. I may do this in my integration up top. So I don't have to come back to it down here. And then, of course, I'll introduce L'Hopital's rule. Yeah, so there are technically 6. And if I substitute that in that, I can condense it to 5. So yes, we can finish it. This is now ending January, and we are, I mean, by Monday, God's willing, I should be finished with, or what I'm going to send you over the weekend is your course delivery chart so that you can help me to track exactly where we are going. So you know every class, what it is that we're supposed to be covering, so that we can finish the syllabus on time. So it is possible. Yes, Adrian, it is possible. We can finish this on time. What I'm trying to do is to spend some extra time on your on these pieces so that we can do your coursework and maximize on the coursework. So by week after next, we have to do our coursework. By the first full week in February, we have to be doing our coursework. All right. So February is next week. I think next week, Thursday is February. By the following week, full week, we have to start our coursework piece because I'll be finished with that by then. I'll finish unit 1 and unit 2. Unit 1, unit 2 is going to be your coursework. All right. So let me stop share.
Sorry, can you add me to the Edicosoft?
Huh?
I'm not added on the Edicosoft.
What about it?
I'm not on it.
That's what I was doing before I came back. I was actually there trying to add some students. So let me just do that for you now since we are here. So that's what I was doing. So while I was waiting on you, I was actually adding some students for waiting on you to finish a question. I had gotten some more. I was adding to the business calculus. See right here, I was adding to some business calc students to it. So let me do Amanda. Anybody knows Amanda? She has not come back to class.
Yes, sir, I know her.
You need to find out if she's doing something so I can know because I've not seen her. All right, Simon, you're there now. You can check for me, please, and let me know. We have a new student to the class. I thought he was going to come tonight, but maybe he just decides to start on Monday. Shumari.
Yes, sir, I'm seeing it now.
All right, good job. Talia is absent again. I don't think Colin is coming back. All right, so let me. Oh, I thought I was sharing actually. All right, let me just wrap up this. I'd given you another example, right? This one here, right?
Yes, sir.
Are we finished with it?
Yes, sir.
Shama, are we finished?
Yes, sir, that's right in the last statement.
All right. So is it continuous at x equal -2?
No, sir.
What say you, Simon?
No, sir.
What about x equal 2?
Yes, sir. Continuous.
You got 1 and -1?
Yes, sir.
And -1 and -1?
Yes, sir.
Topic done. I'm finished with it. I can send you some questions, but I mean, you know, they're all the same questions. They're all the same types of questions. I am going to be moving into a question of this nature. You know what I'm going to do? I'm going to challenge you for the weekend. I'm going to challenge you for the weekend. And I'm going to send you this question. I'm sending you this question as we speak. As we speak. INFORMAT information for MATH3601 CALCULUS calculus 1. All right, so I'm putting that there so that the calculus 2 students don't pay much mind. What time is it? All right, so I'm sending you this question. What I want you to do for me is to go through that question. That's where I'm going to pick up on Monday, God's willing. I want to maybe use the first 45 minutes just to go through this topic, this not topic because I've done the topic, go through with this type of question and be able to give you 2 or 3 of these questions in class. So the first 45 minutes of class on Monday, God's willing. And then we're moving into our first principles. By the end of Monday, I should cover first principles differentiation. Hear me out. By the end of Monday, I should cover first principles differentiation. All right. So I'll end here. Thanks for coming out. I'll give you a little work over the weekend. Just look through this document for me, please. So it is that you can do a little bit of work. So come Monday, you should be good to go. All right, guys.
All right, sir.
Thanks for coming out. Have a good
Yes,
night.
sir.
Cool.
You as well.